Hello there. So now that we know how the first derivative and second derivative describe the plot of a function, let's see if we can make a plot that's basically only based on a few meager facts about the function's value, the values of the first derivative, and the values of the second derivative. So here we have a lot of facts about a function, and these facts may or may not, in fact they almost never will, determine the function uniquely. But all we want to do here is make a plot that could be this function that's being described. And the way I like to do it is I like to have some plotting paper here, and I like to have a pen that's a color that's not going to be obtrusive, and then I like to have some other colors around that help me out. Alright, so let's see. What do we know here? Well, when you see a problem like this, you have to sort of decide what's important. You know, the easy ones to deal with are f of 0 equals 2. Alright, so f of 0 equals 2. So here's 0, so f of 0 equals 2. There. I now know a point on my curve. And you know what I'm going to do is I'm going to cross this out. There we go. So we've already taken care of that. Oh, and f of 1 equals 1. F of 1 equals 1. F of 1. So there are 2 points on my curve, and I don't need those facts anymore because I've already taken care of them. All right, what else can we do very easily? Well, you know, these derivative things are not so hard to deal with. So what I like to do with this is, so we know that f prime of negative 2 equals 0. And that means that it's horizontal at that time. So, you know, maybe what I like to do is I like to draw sort of a light arrow kind of showing the direction of the curve at negative 2. Just, I don't really know the height, but I know that it's doing this. And look at this. We know f prime of x is less than 0. So it means it's negative for negative 2 less than x less than 0. So in this whole interval here, we have, except for at negative 2, we have that the function is decreasing. We have that the function is decreasing. And between 1 and 2, between 1 and 2, the function's also decreasing. Now look, we know the function value right there. So we know the function's also decreasing between 1 and 2. So there's some information that we have. I'll cross this out because we've used it. What else? What else do we know? Let's see. F prime of x is greater than or equal. It's greater than 0 for negative 1. So it's f double prime of x is greater than 0. So that means that the function is concave up here, and it's concave up, so it either looks like this. And what else do we know? We know that we know the limit as x goes to 0 of f of x equals 0. So this tells us stuff not at 0, but it tells us it tells us that first of all the function has to be near 0 someplace. So somehow we have to be, if we put this in, we use this fact here, and we combine that with this fact here. Let's see, f double prime is greater than 0 means it's concave up. Well, it's concave up here somehow, so if it's going to be concave up, it has to either do this sort of thing. But look, what do we know about the derivative? It can't be increasing, it has to be decreasing. Between 1 and negative, so the function almost has to look like that there. Let's see. And look at this. F of x is continuous at x equals 1, but not differentiable. So that means that there's some sort of like, there's a kink in the curve. There we go. And let's see, there, that means it's going down afterwards, so it's going to look like this somehow. Let's cross this out. There we go. we've used most of the facts here. Oh, f double prime, we've used this fact here. F is differentiable for negative 2 less than x less than 0. Oh, we use this f prime. That means that it's smooth. It's differentiable. So somehow I have to get to some sort of a line here where the function is flat. So it's going to have to kind of do one of these things. And we know the function's decreasing here, so let's keep on going. There. I think this plot that I've drawn captures all of these ideas here. So let's double check. Let's just go through and make sure we have everything. So f prime of x is less than 0 for negative 2 less than x less than 0. Okay, so is it decreasing for between negative 2 and 0? The function is decreasing. And between 1 and 2, is the function decreasing here? Yes, it is. Okay, so this is all taken care of. F prime of negative 2 is 0. Yep, it looks like f prime of negative 2 is 0. That's okay. F is differentiable for negative 2 less than x less than 0. Yeah, our curve is smooth here, no problem. The limit as x goes to 0 of f of x is equal to 0. Yep, the limit's equal to 0, no problem there. F of 0 equals 2, f of 0 equals 2, no problem. F of 1 equals 1, f of 1 equals 1, no problem. The second derivative is greater than 0 for negative 1 less than x less than 0. Let's see, the second derivative, yes, it's concave up, so there we go. And f is continuous but not differentiable at x equals 1. So yep, here it's continuous but not differentiable. So now we have our plot. That plot is very far from being a unique representation of what could be drawn to satisfy all those conditions, but it works. And that's good enough for this exercise. All right, let's do some more math.